You're on.
Jack, stop for height with film.
Yeah, it definitely really good space. It looks like way too calm for a boat to be like it's all like still, everyone just like takes a picture, it's all
Okay, so the question is, real or fake? So who thinks it's real? Who thinks it's fake? It's real. What's the name of this cruise ship?
Titanic. Well, Moose.
No, the one before that.
Okay.
The Costa
Concordia.
Costa Concordia. The biggest thing that was in the paper about this, it happened about 3 or 4 years ago, was that the captain jumped ship.
Yeah.
And there was a lawsuit against him, and anyway, that was the biggest news about it. But this is a cruise ship, Italian cruise ship, that got too close to shore, hit reefs, and tipped over, and they had to get all the people out of it. I don't know if anybody died or not. It was so close to shore they could have swam. I'm not sure though if somebody died, but this is real. So this is something that we would be thinking about in terms of engineering for a statics class. So mechanics, the term mechanics. Do you know what the term mechanics means? And those that the half of you that took materials know about mechanical properties. What are some mechanical properties? Who took materials? Put your hands up really, really high. Material and courses cross over, they do. Elasticity,
Yes.
plasticity, ductility, brittleness, strength, toughness, resilience. They're all mechanical properties. Mechanical properties are properties of a material, how a material behaves when what happens. When a load or a force, load and force, they're synonymous. When a load is applied to something. So, we're talking about this cruise ship hitting a reef. Is it being subjected to a load? Yeah, a load. It's being subjected to a force, right? If it crashes into a reef, it's being subjected to a load. And mechanics is also, it's not a property. We're not looking at a property. We're looking at the study of how something behaves when it's hit, when it's subjected to a force. So let's write that down because that's important for us to know. So mechanics behavior of a body when subjected to a load. And this load, you could say, is basically a stimulus. It's something that is stimulating a material to behave in a certain way. In materials, you learned that there are other kinds of properties besides mechanical properties. There are thermal properties. And thermal properties is how a material behaves when we subject it to heat. So a thermal property is how something behaves when you subject it to heat. Optical properties is how something behaves when you subject it to light. So an optical property is light. Electrical property is how something behaves when you subject it to a current. Okay, so there are many different types of properties. In statics, we're dealing with mechanics, mechanical properties. We're not going to be dealing with the properties, we're just going to be looking at the behavior. Mechanics is divided up into two categories, statics and dynamics. What's the difference? What's statics versus what's dynamics?
Forces in equilibrium and non-equilibrium.
Right, and let's talk about it in terms of motion.
So like stationary and moving.
Right, no motion.
But they're both in equilibrium, no?
Uh,
One's no motion, one's motion.
No, I don't teach dynamics, so when you say some of the forces equal MA, does that say it's equilibrium? You know more than me, you just came out of 4A. So when you sum up the forces and they equal to 0, that's equilibrium. When you sum up the forces and it's equal to the mass times the acceleration, do the physics faculty call it equilibrium?
No.
Okay, you know the answer, you can check it out, I don't know, and let me know what the answer is. Statics is a sophomore level class. So you take it at Cabrillo. Dynamics is considered a junior level class. It's one of the first classes you take when you transfer. So the idea of this class is to prevent motion, right? Figure out what forces are on something so that there is equilibrium, so there's no motion. So when we talk about this cruise ship, when it's moving like this in a straight line, what kind of motion is that?
Linear.
Linear or, starts with a T?
Transition.
Translational. So motion translational motion is linear motion. So when I move like this, I have translational motion. But what if I'm moving like this? What kind of motion is that? Rotational. When did it hit rotational motion? When did the ship hit rotational motion?
When it hit ground.
When it hit ground and started tipping. Right? When it started tipping, that's when it was dealing with rotational motion. I'm going to bring some tops into the classroom when we start doing moments. And I bought these really cool ones from the Asian Art Museum. They're all made out of wood. They're really beautiful. I'll bring them in. When you spin a top, what kind of motion are you hoping to get? Rotational. But if you're on a really slick ground surface, what happens? It's rotating, but it's also could be skidding, right, along the surface. And then what's that? When it's skidding, what kind of motion is that? Translational. Okay? So in statics, we're trying to prevent both translational motion and rotational motion. So statics analysis didn't just go into the design of the ship and how the ship will be fine and not fail. It also went into the design of how to pick this big thing back up. So we're going to watch a video on that. And I'm not getting sound, so I have to try something else. This is my first time dealing with two screens that could be different. So I'm gonna have, this is gonna be a learning curve here.
I did stuff out here, we just need
Really?
yeah.
Because yesterday, when I did it on Tuesday, I had to do this, press some button down here. So let's try the easy way here.